Howdy, everybody. We're here for day 11 of Advent of Code 2015. Hope you're doing well wherever, whenever you are. Sorry, I was just sometimes, I don't know, my mind wanders. I was starting to look at the problem already. Anyway, having a lot of fun solving these, thinking I think it's a great way to like kind of remind myself of how to solve these problems because I haven't done them in a little while, and I enjoy solving them. So let's just try day 11. Corporate policy. Santa's previous password expired and he needs help choosing a new one. To help him remember his new password after the old one expires, Santa has devised a method of coming up with a password based on the previous one. Corporate policies dictate the passwords must be exactly 8 lowercase characters. Okay, that's a bad rule. So he finds his new password by incrementing his old password string repeatedly until it is valid. Incrementing is just like counting by numbers. So XX goes to XY, XZ, YA, YB, and so on. Increasing the rightmost letter one step. If it was Z, it wraps around to A and repeat the next letter to the left until one doesn't wrap. Okay. So we presumably just increment the password over and over again. Unfortunately for Santa, a new security elf recently started, and he's imposed some additional password requirements. They must include an increasing straight of at least 3 letters. A, B, C is an example. They cannot skip letters. A, B, D doesn't count. So it has to be strictly increasing. There needs to be an A, B, C, B, C, D, C, D. Passwords may not contain letters I, O, or L, as these letters can be mistaken for other characters and are therefore confusing. Okay, so just don't have any of those. Passwords must contain at least 2 different non-overlapping pairs of letters, like A, B, B, or Z, Z. Passwords must contain at least 2 different non-overlapping pairs of letters, like A, B, B, or Z, Z. Okay. So that's similar to one we've had to do before, but slightly different. The other one was 2 of the same. This one is saying 2 different, right? So we want to look for an AABB. Like 2 AAs don't work, even if they're not overlapping. So the non-overlapping is kind of a double. I like that doesn't matter because they would never overlap if they're different, right? This one meets the first requirement. It has a straight HIJ. It also has IJK, KLM as well, but fails the second requirement because it contains an I. Gotcha. And an L. Yeah. This one meets the third. So it has a BB and an FF. Yeah. But fails the first. Yeah, there's no ABC or whatever. This one fails the third because it only has a double letter. I mean, it has no I, O, or was it I, O, or L? But it also doesn't have an ABC. It doesn't have a run in here, right? B, C, D, C, E, C, G, J, K. Yeah, H, I, J. Yeah. I mean, it fails for both the reasons, but it definitely fails the third because it only has a BB in it. The next password after A, B, C, D, E, F, G, H is A, B, C, D, F, F, A, A. Okay. I think that makes sense. Like if you're thinking about it in your head, you would say the next time this one would the requirement that is bad here is that it's not the third one. It doesn't have 2 different non-overlappings. So it would never happen until the last 4 were the 2 not. The next one would be where the next 2 were non-overlapping, and so the next it would have to be FF because E, like if this is F, so it's already past E. So this next letters would be the next one that this could ever be is an F, and then this would have to be an F, and then these could just be the first 2 letters AA, right? That would overlap, and so that would match. The next password for this is this because you eventually skip all the passwords that start with GHI since I is not allowed. GHI. How big is this number as a digit? Even though there's only 8 characters, each of them are 26, and so this could actually be pretty large. My input is, okay, given Santa's current puzzle, what should his next password be? Yeah, so it's yeah, so I was just thinking about like these things right here. So I am trying to find the next password, right? So I'm given this password as my input. Yours will be different, and it's saying like what is the next one. I'm just trying to think of like how, you know, when this doesn't look big because we count in base 10, right? GHIJ. So like this one will always, this one's never going to be valid until this becomes a J. And then you have to find 2 non-overlapping pairs. And so that would be this right here. AA. Why can't this one be A? Why can't it be ABB? Password must contain at least 2 different non-overlapping pairs. I mean, I know this needs to go to J, right? So GHJ, and then presumably you start AAAAA. That one doesn't work because we don't have another one. The password must contain at least... Yeah, but what I'm wondering is why doesn't GHJ AAABB work? Passwords must contain at least 2 different non-overlapping pairs of letters. Right? Eventually you skip these, and so these are all, imagine these will all be Z Z Z Z Z Z Z Z Z Z, and then you go GHJ, and these will be AAAA. That one for sure doesn't work because it says at least 2 different non-overlapping. The next password after this is this. Like, why can't it be AAABB? Oh, I see. It's because it's this one. You don't get the ABC until here. Gotcha. Okay. So if this was ABC or whatever, or the triple, I gotcha. Okay, so that's the reason behind it. Is like you don't get the triple until right here. Okay, got it. So this, like, the way to say it is like this string doesn't help any of them. And so the first time this part of it helps is this part right here. That's an interesting thing. There's probably like a limited set of values, Oh, and there's a potential to need to skip, right? Like I was saying, like this can be really large. We often think in base 10, and so this is only 100,000, like 10 million, right? I guess there's like 100 million numbers here, but this is base 26. So like we do 8 to the 26 is 23. That's a huge number, right? So there may be some shortcuts we have to take if it doesn't solve quickly, right? Like, so you could imagine the shortcuts being something along the lines of, if I ever encounter an I should just go to J, immediately move I to J. That the same thing applies with O or L. If I ever find an I, O, or L, I immediately increment it, and everything after that becomes an A. And then I test. So we'll see. That's probably something we need to do. It does give me 2 test cases though, right? So I can test these to make sure they work. But I think the general pattern is I need to find some kind of incrementing tool. Say like, hey, can I increment to the next one? Just give me the next password. And then can I check if the password is valid based on these? So I'm inclined to copy and paste these and put them in my problem. How do I find these ones? I'm just thinking of how I should represent it. I'm like, okay, I should be doing the increment. The first thing I should do is just try and increment. But like, how do I increment? Do I want to do these as bytes? So it's really easy, like U8s, so I can do it really easy. It wants to know what the password is. So I need to turn it back into a string eventually. I mean, that's not too hard to do. But bytes might be easier because then I can just do a comparison. Like, is this one greater than this one, and is this one greater than this one? Yeah, I just have to do those checks. And then these I can just say, you know, are they either of these ones? And then password non-overlapping, again, because I'm using bytes, I just look for pairs that are equal and find 2 of them. Okay. Yeah, and then the increment is the, how do I increment bytes? Probably just, I mean, I can just literally do what it says right here, right? I probably pick the last one to increment it. If it was a Z, it wraps to an A, and then I do an increment on the one before that. Okay, so let's try this. I do want it to be bytes, so I think we'll try it with bytes and see how hard it goes. So we'll have an FN increment, and you give me a cur vec U8, and I will give you a new vec U8. Oh, it won't be a, it'll be that. So let mute next equal cur.clone. We'll return next when we're done. So how do we increment this? I mean, we just start at the right and we keep incrementing until we don't wrap. So I don't know exactly how I'm going to do that. We'll just start with a loop. So we'll say if next pause does not equal z, then next pause plus equals 1, break. So that's if it doesn't equal z. Otherwise, we assume it equals z. So we can just say next pause equals a. And now pause minus equals 1. Why doesn't it like this? Oh. This will overflow though. So I say if pause equals 0, break as well. Right? If I ever get to the beginning of the thing, if I've ever replaced the z with an a at the beginning, I don't want to keep going anymore. I think that's right. Ooh, I also want to do this part. Next pause equals, maybe I just do them one at a time. So if the one I'm ever incrementing is an I, I want to make it a J. So I say, oh, but I'm incrementing J. No, this is not how it is. It's not in here. It's in here. After I've incremented, I want to check if next pause equals I. Because if this is ever an I know I need to, I should just immediately change it to a J. So I should say next pause equals J. And then everything after it should be, I should switch it to an A. So I should say for I in pause plus 1 to next dot lang. Next I equals A. Like that. I think that's right, right? So like as I'm going through these, if it's not a Z, I know I'm going to increment it to something and it's not going to overlap. But I also want to check if I ever get an I want to move it. I want to immediately move that to J and everything after it should become an A. And I guess I want to do this. for O, oops, and L. But it won't be a J. I just want to increment it. Is fine. And then I make the rest of them in a thing. So I'm gonna make a note here. So this is like a, if I ever get a bad letter, I know the rest of the passwords will fail until I go to the next. And the rest would be A's. I mean, this is, hopefully that makes sense what I'm saying. I'm just worried, and I don't know. Maybe it will never be the case, but my inkling is like, imagine this is pretty big, but imagine like the next valid one isn't until like this one's an I, or it loops far enough that this becomes an I should say. Oh, maybe that'll never be the case and it won't matter. So maybe this just depends on input, I guess. But imagine this goes to an I. There's no reason for me to like check all the operations of the I's. This may be a premature optimization, but we'll see. Anyway, I think that's our increment. Right? And then now we just need to create a valid function. It's going to be a vec of u8. I'll just return bool. So what does part 1 look like then? It'll be like let mute cur equals input dot trim dot map. And we go while we need to increment it once first. I can do this in a loop, right? Cur equals increment cur if valid cur break. What doesn't it like about this? Oh, okay. Probably same with here. It'll be cur dot iter dot map. Something like that. Why doesn't it like that? Oh, dereference. So we get the characters, the input, we trim the new lines, we turn them into U8s, and then we call our increment function, check if it's valid, and if it's ever valid, then we can break. And then we just go through till we're done. So now we just have to do these rules right here. I'm just gonna put right here, I think. Passwords must contain one increasing straight of at least 3 letters, like A, B, C. Okay, so I think I can just do a bunch of things like this. So we'll go like if not password dot Windows 3 dot map. So it'd be W0 equal W1 minus 1 and W1 equals W2 minus 1. Like that? Is that right? How do you do it? What's the simpler form of this? That might be a good question to ask AI. Basically, what I'm saying is I'm go through windows of 3, and I'm going to map them to. I'm going to check, is the first one equal to, is the first one bigger than the second, right? And is the second one bigger than the third? Is that the only check I have to do? The first is bigger than the second. No, one bigger than the second. Yeah, I think those are the only 2 checks I need to do. Just make this one has to be strictly 1 bigger than this one, and this one has to be strictly 1 bigger than that one. And if I ever find that pair, I think I'm good. Okay. If I don't, I just need to find one, any. So if I go through them all and don't find any, it fails. Okay. That's that. Passwords may not contain the letters I, O, or L. So I can just say if password dot contains like that. Why doesn't it like these? It wants me to put these, that. Okay. So I basically am just checking. I'm saying, do I have an I or an O or an L? If I do, I return false. Okay. Password must contain at least 2 different non-overlapping pairs of letters, A, B, or Z. So that one I think I can just do like let pairs equal how do I do? I probably want to do like a scene thing. If W0 equals W1. So we insert that, and then we say if scene dot lane greater than or equal to 2, return true, like that. That's the last one. So this can be simplified. So I think, well, we can actually just say this. I think. Is that right? So I basically just go through, I go through each of the windows and say, hey, are the two the same? And if they are, I insert that one. And once I've gone through all the windows, if I've seen two unique pairs, two different ones, it works. Okay, let's try it. 3.8 milliseconds, that's pretty fast. Is it right? Okay, it has XYZ, interesting. It's got XXZZ, and it doesn't have any eyes or anything like that. So that does work, I think. What was that? Settings? Okay, I don't know. That's there anyway. Oops. Let's try it. Submit. Hey, yo, that's the right answer. Okay. Santa's password expired again. What's the next one? Okay. Let's see. I think this works. Well, let's do it again and just see. My only concern is there may be, like, maybe the first one's really easy, but the second one's not. Let's just we'll try it though. I mean, the easiest, we can refine this later, but here's the easiest solution: is we'll just do this loop twice, right? It's silly, but we do the loop twice. Wait, why? Oh yeah, this is a string. Okay. So I had to go through the first one twice. Oh yeah, it's not fast. Okay, that would make sense too. Like you could solve that one like that. That's right. Okay, we completed day 11. Okay, it took me a little bit to figure it out, I think, to understand. I was really stuck on this example right here. And it's just because I'd forgotten this rule. So that took me some time. So let's try and clean this up a little bit. First of all, we know that part 2 feeds into part 1. So I think what we should actually do here is like let password equals p1 input. And then we just pass that into that one. What doesn't it like about this? Oh, I just need to borrow. So you only do it once. Is that still the same? Yeah. And I actually think like you probably just do this thing. So I have an increment, I have a valid. I should probably have a fn find next valid password. So you give me a password of stir, and I'll give you a string. Like that. So then this is just find next valid password, input dot trim, something like that. like that. Yeah, I usually do these P1s and P2s. These are still the same. So I mean, it's a little absurd. But hopefully this makes it clear. Like, given a password, turn it into some bytes, and then I'll increment until I find a valid one, and then I'll turn it back into a string for you. And then so I just do that twice. And I change this one up a little bit because part 1 feeds into part 2. Could these be simplified? I actually don't think I have to do this part right here, because I think my increment does that. Yeah. The reason why I don't have to do this, I'll leave it in there. Because imagine if I ever have a password that has one, the first thing I do is I increment, and my increment makes sure I never have one of those, right? So it's a little confusing because I was, okay, well, we can try it without it. I can just comment this out and see, does it change, how much does it change the time? Almost nothing. Okay, so this part doesn't really help any. If you need to optimize for longer increments, this part would help. So I guess I won't keep it in there, but I think, or maybe I just should, because it feels more readable to like actually check here, because you're saying like, oh, here's how I check the first constraint, here's how I check the second, and here's how I check the third. Yeah, I'm just imagining a case where, like, if you ever hit an I anywhere up here, and maybe it's just my input, so maybe your input differs, and this may actually be pertinent. That would be interesting. You should tell me. I'd be interested to know if like this ability to skip is useful. Like, it doesn't appear like it helps me. Okay. Sorry, I think I hear someone coming, so maybe I should wrap this up. Anyway, the increment, I'm basically just incrementing the values, and then I just check each of the constraints one at a time. There's a potential, I think I will wrap this up because I hear someone coming, so I probably have to finish this up, but let's just say there's probably a potential to optimize this valid, so if you have a way to optimize it, that would be interesting. This increment, I don't know, I feel good about it, although because it's literally just doing what the thing said, but maybe you have a more interesting way of incrementing it, and if that's the case, I'd love to see it. So yeah, send me your solutions. I'll upload this, and you can send me your solutions, and we can compare and contrast and see how we do. So talk to you next time. Bye, everybody.